Hello, Mario. In this video I'm going to just take a real basic look at leveling and what the optical leveling and what an optical level can do. So we're looking at what we call differential leveling. So let's just get into it straight away. Now this looks like a pretty busy picture here. That wasn't my intention when I started it, but that's how it ended up. So here is our level set up over our tripod, defining a horizontal line of sight. And that is all that a level does. It just defines a horizontal line of sight. Nothing more, nothing less. They do come, some levels come with a horizontal circle that you could measure rough angles with, but that's just a sort of added extra. All they do is define a horizontal line, and from that horizontal line we are able to determine the difference in heights between different positions and objects and what have you, as I've shown here. Now pretty much always the first sight that we take when we do our levels is called the back sight. Usually that may be onto a peg with a known height, but not always. In this case I've called it peg A, and I haven't given it a known height because we're just going to be looking at height differences in this instance. So there's our back sight to peg A. Now that determines in some ways for the setup, for each setup with the level, that determines the reference plane just for that setup. Every time we move the level we get a new reference plane or setup. So in this case here the reference plane is 1.267 meters above peg A. Then if we're going to another point that we're going to then move on forward from, we call that the foresight, and in this case I've said peg B is a foresight, and the reading on peg B is 3.207. So straight away we can see just from the picture there that we can see more of the leveling staff. 3.207 is more than 1.267, and we can see that the difference in height between A and B would be negative. B is below A, and we usually show that as a negative. So to work out the difference in height, what we do is we go the back sight minus the foresight. So here I've got 1.267 as the back sight, and the foresight is 3.207, and if we take them away we get minus 1.940, and that is the difference in height between A and B, and it's got its minus sight there so we know that it's left, so that we know that it's got its minus sign there so that we know that it is below A. Now at each setup we can take sights to various other things which are sometimes or generally called intermediate sights, and in this case here I've taken a level or taken a reading to the soffit of the, well, it's supposed to be the play school house, but some may beg to differ. There's no round window. I don't think. We've got all square windows. The round windows are on the back of the house. So we take a reading onto the staff and we hold the staff upside down under the soffit. Now for these readings, the upside down readings, we show the reading as negative. So as for previously where we took the back sight minus the foresight, we take the back sight, in this case minus the intermediate, so we get 1.267 minus negative 1.062, and if we work all that out we get 2.329, and that would be the difference in height between A and C, and as it's positive, C would be above A. The difference in height between A and B is negative 1.940, B is below A. And there you have it in a nutshell, really. Real basic levelling. The level, an optical level, defines a horizontal line.